the data types, which is called as a typecasting, renaming the columns, uh, creating the dummy variables, right? And this is where we spoke about, Ganesh, the flooring and the capping, right? So we said we will use the NP clip, which is a NumPy clip function.
Right.
And what we do is we find out the first percentile and the 99th percentile of any observation, right? And we use that to clip it. So for example, in this case, you can see the first percentile for fair is 0 and 99th percentile is 249. So what does it mean 99th percentile is 249? Anyone in the class first? 99th percentile is 249. What does it mean? For fair, let's say the fair is in pounds, right? And I'm looking at 99th percentile as 249 point something something. What does it mean? Online folks? Something? Close enough, but not quite. So what it means is that 99% of the passengers who were there in that ship paid the fare of 249 or lower, right? So only 1 percentile of the people paid higher. So that's why you can see these are the extreme values, right? So somebody paid 512 pound when 99% of the passengers paid that much or lower than that amount, 249 or lower that amount. So it makes sense for us to clip it or do the outlier treatment, right? So you can see this also, the most of the values are focused till over here, but there are some extreme values. Like you can see there's a small bar that you can see over here. So these are the ones that we have to really fix, right? So how do we do that? We found out what is the first percentile and the 99th percentile. First percentile was 0. 99th percentile was, I think that's where Nidhi, you were observing that I am not typing the correct number. It is 249, right? Not 247, 249. So it should be replaced with this number right over here. And I'm not running the code, but when you run the code, you will see that the max now has become 249. And that will help you address that outlier, right? Now, if you don't want to remember the value and you want to run an algorithm which will do it automatically for you, this is the one that you're looking at, Ganesh, right? It works exactly in the same way as what we have done for the dummy coding. So we are iterating through all the columns in the Titanic data. We are computing the first percentile and 99th percentile for each of the numerical columns, right? It will only compute for the numerical columns. And then we are grabbing the values of that. And then we are taking those values. Basically, we are storing that in the object called outlier. Outlier is going to have two values, 0 and 1. Which class you have to go? AI02. Rashmi, do you know? No? Okay. You are coming first time? No, yeah, for the class. Okay. So the first percentile and 99th percentile we are computing, and then we are storing them in the object called outlier, and then we are grabbing the first value and the second value of the outlier, and it's going to do automatically for all the data points. So you can see over here, it has been automatically replaced by 247. Ganesh, does that remind you something?
Yes, sir. Yeah.
So you can just, if you don't have it, I will just share this code with you in the chat window, and this way you can run the outlier
Yeah.
for all the numerical data set, right?
Yeah.
But like I said, I mean, data cleaning is more art than brute force. So you should pay attention to what each of these variables are, whether this makes sense, that makes sense, right? And plan accordingly.
Yes, sir. The German credit card was like very challenging, but in the
Yeah,
process,
yeah,
learned a lot of things.
that's correct. I will give you even more challenging. That's very, very messy data, which is lending card data. So this is a real data from a lender in the US, which is a P2P lender. P2P, does anyone know what is P2P? Peer to peer. So I can lend loan to Amarnath. Amarnath can give the loan to me, right? So it's basically that data. So I'll give you towards the end of the class for more hands-on experience with messy data. Hmm?
So do you have a perfect logistic regression treatment for the previous, I mean, though we have submitted the assignment, do you have a perfect treatment with solid techniques to handle it, sir?
Right. Perfect treatment meaning?
like each one of us would have approached it in different ways. Do you
Uh-huh.
have one
Oh,
version of
okay.
yours, like, which
Ideal
can
way.
be
No,
shared
I
with us?
don't have ideal way. I mean, so once we cover all the different approaches, Ganesh, like in terms of all the different types of modeling approaches, we will see how to combine all of them and see what is the best output that we get, right? But can I tell you like a solution which is going to work for all the data all the time? No, it's just trial and error.
Okay,
Sorry, you were saying
sure.
something, Amarnath? P2P. Yeah, I mean, it has been there in the US for a very long time. Fintech revolution is happening in India as we speak, right? I mean, in India also, it's about 7 to 8 years in making, all the fintechs. So once you have typed in this code 34, let me know you're good to go or not, whether it's working for you. Only the iris, nothing else but iris. And if you're doing this in Jupyter Notebook, you will have to install this package called GraphViz. It will not be there automatically. So you'll have to install that package. And we are gonna first talk about the mechanics of the code, and then we'll talk about the concept, which is in the article number 35. So let me know once you can see this output on your screen, which is there in article number 34 in my blog, datafy.com. And we will only cover iris, nothing else but iris. Does anyone know what is the password for Reva student or Reva staff? Eh? All small, all caps. This is for the staff or the student? Staff. Let me try. Reva at 43. Okay, thank you.
Yeah, this code is done for decision tree, and I can see the tree.
Okay, awesome. We'll wait for others to confirm as well.
Okay.
Email ID and my password. Achha. Okay, got it. Reverse staff. Uh-huh. Oh, thank you.
RB sir, I'm getting some errors. I'm trying to do it in Jupyter notebook. And
What does the error say?
uh,
Hi.
failed to execute Windows path dot. Make sure GraphWiz executables are on your system path.
So you don't have the GraphWiz installed.
No, it's
So
installed. I did that. Can I share my
yeah, I
screen?
know. So but I have to put the same one here. Yeah, you can share. I'll figure it out. Thank you. Yeah, please go ahead and share your screen.
I have shared it.
Sir, I have to face it.
No,
I
I'm
have to
not able
face
to see
it.
that. Sorry, I'm not able to see that. Now it's coming up actually. No, hold. Something else just came up.
So here I just installed GraphWiz.
Yeah.
I tried to import and check for the version, which is .2. I'm doing this data, which to run fine. But when I'm saying that GraphWiz.source of .data, it's giving me exception, failed to execute.
So come down. What is the error that it gives you? Can you just do a quick Google on this error? I think this is something related to the GraphViz only. Just do a quick Google on this error. Let's see what we find out.
Yeah.
Anyone else who found this error? Or you have
Yes,
your
sir.
code working?
I also got the same error, but I started doing it on the collab. It works without
Colab,
any
it will
issue.
definitely work, but yeah, Jupyter Notebook may have certain dependencies. It's not displaying? Okay. I'll wait for others to also see what errors you're getting, and then we can troubleshoot it together. And in the meantime, people who are getting some errors, just start Googling and seeing if you can find out something about it.
Okay, I will stop sharing the screen. I will try to resolve it.
Please. Which section you're in? Same? Okay. I thought maybe somebody else. Okay, anyone who figured out how to make it work in the Jupyter notebook? Colab, I know it's working for most of you, but Jupyter notebook, did anyone figure out? Or you're still working through it? Anyone?
I'm still working through it. I have not found any solution yet.
Okay. Got it. Let me see if I can also dig up. Yeah. So most likely it seems people that this is a path issue in the Jupyter notebook, and the fix may not be straightforward. So I'll give you some time to see whether you can figure out something from over here. So one of the links I found in the Stack Overflow, right? And this is the actual official library link that I'm looking at right now. Let's see if I can find something from here as well.
So when we do a pip install from within the Jupyter, where does this get installed by default?
It will be installed in your default library. So if you just type on the command prompt pwd, that will tell you where exactly it is being installed. Let's see if I have the Jupyter collab, or basically the Anaconda over here. I do. Because I have moved away from the Jupyter long time back to the collab environment. So a lot of these things may not necessarily be straightforward.
One more question. Whichever link I'm checking everywhere, they are talking about .exe.
Okay.
But in my installation, I have only .py. So maybe it could be because I installed the GraphViz, it would have installed the latest version. And maybe that's the reason. I'm not sure because I cannot locate .exe. It's only .py for me.
Yeah, got it. Okay. Visual Studio, it has fired up. Just a second. Anyone figured out in the Jupyter environment? Let's see if anyone has it working. How many of you have working in the collab? Okay, Amarnath has it, Rashmi has it. In the class, others, Pranesh, still working for it?
I did on
Yeah,
collab.
yeah, Nidhi also has it. Okay.
I have it on the collab. I'm checking in the Anaconda. Like it shows like it is installed in the like this.
Right.
I share my screen.
Okay.
It shows.
Sure.
RP sir, I am doing it in my virtual environment.
The virtual environment meaning collab or something else you're using?
Python VN.
Okay, but what is the underlying like engine there? I mean, so does it really work on? I'm not too familiar with that, but maybe you can just give us a sense of what you're doing, right?
No, I just created a virtual environment on my local. A virtual Python environment, and I'm not using the one of my global or the laptops one. It's just a local for the session.
Yeah. So then it just depends on what you have installed basically in that virtual environment. So it should be straightforward from there. I mean, just like you're running in your local environment.
Yeah. So that's why I'm actually installing everything. I'm doing pip install everything before I start anything in the notebook.
Yeah.
So it has got it, but still.
Okay, got it.
Surprisingly, I can print the version of it, but it's not in the path.
Yeah. So let's try it this way. So I'm going to go to the Anaconda prompt, right? And the best way of doing that, if it is not installing from there, I believe, oh, nobody can see my screen. So let me just share my screen as well. And this is completely, something that you can avoid if you're in the Google Colab environment, because that a lot of dependencies are naturally taken care of. But let's see. So if I just go in the Conda environment, everyone knows how to go to the Conda prompt, right? Which is you just go over here and search for Anaconda prompt, right? So you go to the Anaconda prompt and then you'll be good to go. So I'm now gonna find out what is the command for installing. Okay. Conda install graphics. Okay. So let's try this way also. I know some of you have already tried the pip install. I'm gonna try this. Let's see if it works.
I did this, and
huh?
then it was giving attribute error. I did this syntax only in the Jupyter notebook, and then it was giving attribute error.
Oh, is it? Okay.
Yeah, and then it says like a stack overflow. It says like you have to put the file in so and so directory. So.
Got it. Yeah. Huh? You've used this one. It's not working. Okay, so there is some package dependencies which are there, right? So, for example, I think it may be requiring certain other packages. I'm not too sure. You'll have to investigate that, but give it a try. If not, then let's switch over to the Google Colab environment. I mean, everybody has a Gmail. Not necessarily that difficult to set up that environment. And how many of you have used Colab earlier? Everyone? Everybody's familiar, right?
Yeah.
So then we can try. Otherwise, let's switch over to the collab environment, right? You can obviously download that file later on and then save it in your local Jupyter repository if you want to. But let's just for this purpose, because even some more advanced packages that we're gonna do today, like a random forest and all of those things, you will find it difficult to do it there.
But sir, like in real project scenario, if we need to work on the Jupyter, then how we can solve such kind of issues?
We rarely work on the local machine actually. We very, very rarely work on the local machine. We do it mostly in the cloud.
Cloud, you mean like Google Colab, or is there any other tools which is used in the
AWS, Azure,
okay?
Google Cloud. There are many, many cloud providers, right? Because when you're looking at the real time data or the real world data coming in real time, that's significantly difficult for the local machines to handle. So we rarely run anything on a local machine.
Okay.
Yeah. Correct. Correct. Yeah. So Amanant was just telling that he has tried some of this in the local environment. It rarely works for him. So I just updated the package as well after installing. I just did the conda update GraphViz to see whether that works or not, right? So let's see if then we can make it work. I'm not too sure, but I'm going to try that. So I will say import GraphViz. This is the first sign whether this is going to work or not. Import GraphViz. Graph. Typo there. GraphViz. No package called GraphViz.
I think I can make a local build of the library on my machine. I will just download the source code and do a build of it.
Okay, we can try that. Yeah.
But
So I
Ashish
mean,
sir, it's not the first time I am facing such kind of problems, but I'm literally, I'm having such a powerful machine at my exposure and then not able to execute so many things.
No, you can do in the Google Colab and just point to your machine also. So just because you're using Google Colab doesn't mean that you cannot use your machine, right? So I'll show you how you can do that. So over here in the runtime, right, you can say change run type, and right now hardware is none, right? So that means I think it's mostly leveraging your own machine. But if you select the GPU, then it's running on the cloud. If you select the TPU, then I think it's running on some other machine where you have more power. But if you select none, then it's mostly leveraging your local drive or the local machine. So it doesn't mean it's running on the cloud actually. What it means is that the environment that this is using is coming in from the cloud. So basically, once you close it out, then everything like the graph vision, all of those, they are not installed on your local machine. So they are actually being leveraged from the cloud, where I mean all the dependencies are handled and taken care of. But you're running your code on the local machine.
I got you, sir. I wanted to point out was like if I have to use the Colab or any other cloud service provider, I have to be online.
No, you can use it. I mean, like over here, like I showed you in the runtime, you can select your own runtime, like your machine.
And then I can, without internet connection also, I can use that.
No, no, I don't think without internet connection it would work.
That's a challenge. Okay.
The reason is because the packages are not installed on your local machine,
It's a
right?
cloud.
So
It's a cloud. It will not work without internet.
correct, yeah.
I
The
get it.
packages
That's
are,
why it's of no use for me like this.
yeah. So you can read more about it over here, or you'll have to go through one by one and create your environment in a way where all the packages, everything is up to date, right? So you'll have to do some research on the GraphVis, for example, right? What are the dependencies, like the link I've shared with you, the Stack Overflow link? You may have to go through some of them to really find out what are the dependencies and how do we really make it work, right? It doesn't mean that you cannot use your local environment. It just means it's going to be slightly more challenging for some of more advanced work that we're going to do. I mean, if you're doing the pandas and numpy, do it all day long, no problem. The moment you go to the more advanced model like a decision tree, random forest, other ensemble techniques, you may need to have certain dependencies taken care of.
So to work on the AWS or Azure, do we need to are they providing free account, or do we need to pay
Yeah,
some?
this is free. I mean, for like some of the basic stuff that you're doing, but it has limitations in terms of the speed, right? Or the memory basically that you're gonna have allocated, or the machine RAM basically, to be more technical about that. But if you want to go more advanced, you can take a subscription package from them.
Is there any other tool similar to the Google Colab?
AWS is there.
Okay.
And then you have other providers as well. Them, like pretty much all the SAS companies are now providing the cloud environment. It's pay per use basically. Depending on how much you're using, you will be able to use that much.
Mm. No, but Google Colab, I don't think they have any kind of limitation, or we need to go for subscription. We use some heavy
Correct.
packages. So
That's
that
correct.
is the reason I wanted to know if there is anything like this.
I am not aware of, at least for the basic level, any limitations actually. I haven't run into the problem where they told me, no, you cannot run it.
Okay. I'll try AWS in that case.
Yeah. I just did the pip install. Let's see if it works. I don't think it's gonna display. I'm gonna show you the other technique also, but that's not necessarily very convenient and the tree will not look that good. But let's see if I cannot make it work, then I'm gonna show you the other one. So I'm just copy pasting my code from Colab into the Jupyter notebook to see if I can make it work. Okay, till now it's good. Let's run it. Unexpected indent. Where is it? Here. Okay, so this runs. I'm gonna do the dot data. This also runs fine. Graph. Okay, so I'm getting the same error. La, 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 la. Yeah, it's some sort of path problem actually. Like it's not putting that in the right path. That's what it looks like.
Sir, I have tried to edit the path via code for my session and then restarted my environment also. It did not help.
Okay. You want to share your screen and show us how you've done it? Pranesh, you want to do it? Yeah, so Pranesh has figured out how to make it work in Jupyter Notebook, so he's gonna share his screen. And I'll mute myself, Pranesh, so you can talk. Yeah, please. Okay, why don't you share the path then, and people can leverage that.
Did you try executing this and it worked for you?
Yeah, it worked for a couple of people, so they will share the code, right? So, and then we can see what we have to do to make the changes accordingly.
I doubt actually. That's why I'm asking. The reason is that's the source code, and I will download and do a compilation on my own. But I don't see for 2.8 any zip available here.
No, it worked for Pranesh here and Srivala. So Srivalsa, sorry, Valsa, right? Yeah, so they will share the code, or I mean the link where they found it working. I believe Srivalsa has already shared this, right? So you can just take a look from the link. From there, take 3.00 dot zip file. So there's a file that is there, right? Huh? You want to unmute and talk, Shivalsa? That might be good.
Yeah, so I have shared the Stack Overflow link and the download link for the Windows download actually. So you can add the bin path to the system path, then it should work.
Can you share your screen as well, like how you've done it, so that others can also follow?
I haven't done it in my system, sir.
Actually, there's no zip available for 64-bit machine. That's the one point. All are exe installers and no zips. And moreover, the link talk about 2.8 and the latest stable version is 3.0. So that's why I was saying that probably it might not work and I have to make a new build. Anyway,
Okay.
sir, please go ahead because I will do it on my free time. I
Yeah.
will make a new build for it on my local.
Yeah, so Pranesh will share, I think, in some time, like how he has figured out it working. So I know, this is not necessarily a straightforward solution, right? So you are encouraged to do it in the free time. Otherwise, we'll spend, like you said, Krishna, a lot of time just troubleshooting this, right? So shall I move forward in the Google Colab environment then, people, and give it to you for you to try out in terms of those settings, because there's clearly nothing wrong with that package. It's just about the packages, connectivity with different things, and the pathing of that. Some bug is there.
Yeah, yes, please.
Okay, fair enough. So then I'll share my screen, and Pranesh, once you have something, you can come back and then report to the class, right? So let's go and look into the Google Colab environment, people, right? Because that's the main thing in terms of the working of the model, right? So this is what we are doing. So we are installing pip install GraphViz, or we are installing the GraphViz using the pip command. Can you hear me loud and clear, everyone?
Yeah, we can.
Okay, I will just change my audio so that people in the class can hear you as well. Just a second. Oh, device setting is already live. Okay, fair enough. I hope you can still hear me. Quick confirmation, yes, no?
Yeah, can hear.
Okay, perfect. So the first thing we're going to do is install the GraphViz, import the GraphViz. We are loading this data called Iris. Are we familiar with this data Iris, people? Yeah, you worked on it, right? So this is the flower data. Then we are importing from sklearn import tree. Tree is the method that we will, or tree is the algorithm that will be used for building the decision tree over here. We're going to import the numpys and the pandas as the usual things. Then we will load the iris data. And for now, you can just follow along with me, and I will spend more time talking about that. So what we're going to do is we are building a classification. Why are we building a classification here? Anyone? Correct. That's correct. So there are three different flower species over here: Setosa, Varsicolor, and Virginica. So we're building a classification algorithm to separate out these flowers. Does anyone know how many flowers do we have for each one of them? Like in the original data, how many flowers do we have? Just read the description, you'll be able to tell. How many different, so there are three different flowers: Setosa, Varsicolor, Virginica. The question is, how many each type have in that data? How many Setosa, how many Varsicolor, how many Virginica? And you can read from the description itself. It just tells you there. 80? 50 each, correct. Yeah, so Pranesh is correct. We have 50 each of these flowers. And the algorithm is trying to build algorithm is trying to build a classifier where we can separate out the flowers from each other, right? Because that's the job of a classification model, trying to classify things into different buckets, right? So that's the main intention. So let's go ahead and see how we are doing it. We are using classifier, decision tree classifier. If you're using a regressor, then it means it's a regression problem, right? And we are looking at the criteria, max depth. Ignore all of this. You may say, okay, why are we ignoring it? Because we haven't talked about that. So that's the topic for the next segment. I'm just going to show you the working of the tree. So once you've done it, then we are fitting the data like we've done in any other algorithm. So you create the instance and then you fit the data. And I'm fitting on the original data, complete data. I'm not doing the train and test. I'm doing fitting on the original data, complete data, right? And then we are doing some other things in terms of creating the data frame. And this is where the tree is actually getting configured, right? So I'm just trying to make sure that I can visualize the tree. So I pass on my instance, which is the classifier. Out file is none. I don't want to see any out file. Feature names is basically the original data X. What are their names that we have to pass on as the array? Class names is the names or the classes of your dependent variable that you have to pass on, because that's how the tree is going to be labeled. Filled meaning you want the color to be there in the tree. Rounded meaning you want to round out the numbers, and if there are any special characters, you want to display them as well, right? We'll touch upon this code one more time. And then once you've done your dot data, you can call it anything you want to call. You don't have to call it dot data. Let's say you call it X, then you're going to pass on the X over here, and GraphViz dot source X, and then you display the graph, right? And I want to talk about what this tree is first, and then talk about the concepts of that, right? Okay, there we are, right? So this is the tree, how it looks like. So you can see we are starting with a root, which is the parent node, right? I mean, it's sort of like, lopsided tree. So tree generally begins with the root and then you have the branches. This begins with the root and then you have the branches coming down, right? So we are beginning with the original node. It says you have a total of 150 observations over here, 50, 50, 50 of each type, right? And it is applying a cut which says if the petal width is less than 0.8, you will come on this side. If the petal width is not following this criteria, you will come on this side, right? So the first thing it is doing is basically saying if your petal width is less than 0.8, there are 50 flowers like this. And all of those 50 flowers are setosa. So it has automatically done a classification for you. So it says I'm applying the first cut, which is the petal width. And if the petal width is 0.8, all of the flowers are setosa variety. So you can see this is the first node it has created, and this is the end node. End node meaning why it is end node? Can you split it further? There is no reason to split further because it's a 100% pure node. I have 50 flowers, and all the 50 flowers are setosa variety, right? So it cannot be split further. If this criteria is not met, you're gonna be on the false side. And then it is saying, okay, now I'm applying my second criteria, which is if the petal width is less than 1.75. So that means if the petal width is more than 0.8, but less than 1.75. If this criteria is true, then you come on this node. If this criteria is false, then you come on this node, right? So if this criteria is false, so that means it is not less than 1.75. It is in fact more than that. Then you have 46 flowers like this, and almost all of those flowers are virginica. So it has already given you the cut. So from here, intuitively, you could tell that the smallest flowers are setosa and the biggest flowers are virginica. And Varsi color is somewhere in between, right? So that's how basically it does, right? And the color coding over here signifies what? Anyone who can intuitively look at this and tell me what is the color coding?
Differentiate between three groups.
Yeah, so differentiate between the different classes. So Setosa, for example, is this color, peach, brownish, whatever you want to call that. Uh, your Varsi color is green and your Virginica is purple. And when you have a white, what does it mean?
Will still go forward.
White means everything is mixed up. It is mixed up, right? So for example, you can see the original node was all white. Why? Because it is 50, 50, 50. All the flowers mixed up. Everybody is equally represented, which in the decision tree lingo is called the highest amount of impurity. When you have the highest amount of impurity, it will be white color. When you have the separation coming in, you'll see the color getting separated out, and we'll see that more in the Titanic. And there are concepts like Gini and entropy, which we'll be talking about as well. So I hope everybody has the tree working now, people. And then you can save it, by the way. So for example, you can say graph.render, and you can call it whatever you want to call that, right? And then if I have run it, let's see. No, I haven't run it. No, I have run it, right? So you can see this file is saved. Now I can go and download this file. And then I can stick this PNG file wherever I want to. Okay, for whatever reasons it's not able to pull up. Let's see, I can download the PDF. It becomes easier for you to visualize, right? So then I can go and present that PDF as a separate tree. So this is what a decision tree is. Decision tree is a simple criteria where you start with the original data, then you continue to split until you get more purity, right? And we'll talk about that as we go on from the, please. That is what the decision tree will figure out by itself. So we'll talk about concepts such as impurity and the information gain. So it looks at all the variables and all the possible values within the variable to figure out where I can drop the impurity the most. And I'll talk about that. Just hold on to that thought, yeah? So now what I'm going to request folks for you to do is go through this article number 35, and it is laid out in the format where you have to keep on clicking on it, right? And go till about slide number 10, till slide number 10. If you can read and confirm, and people who want to take a break, you are free to take a break in between as well. But from slide 1 till slide 10, if you can confirm that you have gone through it, we'll take it from there. That talks about some of the questions that we may have, how a decision tree really works. Hmm. Wait, the cuts. Yeah. We'll talk about. We're not doing it by hand. I mean, that's the algorithm, but algorithm is doing in a certain way, which is what we're gonna talk about, right? If you just no, it won't be possible by hand. I mean, you can do it if it is a small data, but I mean, if you're gonna have thousands of rows and all of that, it's just not possible in that amount of data. But by hand, I mean, some people demo it how a decision tree really works in a small data. That can be done. Just go to datafy.com and article number 35. I'll send the link anyways.
Slide 2 says like it is classification or regression. So classification I can understand, but how it is regression also?
I will talk about that, Nidhi, in a minute.
Okay.
If you just go through slide number 1 to 10, some of the questions hopefully will be automatically answered, but we will definitely spend time talking through it. Yeah. Yes. There are. We'll talk. Pruning is part of that. Yeah. Absolutely. Mm-hmm. Shift as well. I hope you are able to navigate. So it's just click on the arrow button, and that's all you have to do. So just glance through, maybe take 5 to 10 minutes to go through slide 1 to 10. And if you look at the footnote, like there is a small number there, right? So that's what I'm actually saying, slide number this to this. So 1 to 10 is what we're looking at, because that talks about the concept of a decision tree, how it works and all of that, right? And I will go slide by slide, so you don't have to worry about if I don't understand anything. I will definitely cover it, but you should read first. It's a supervised. TCA is there, clustering is there. We have market basket analysis. All of them are unsupervised.
Hi, sir.
Hi.
I'm able to run graph in my local installation now.
Okay. How did you do it?
So when we do some pip install, the installation was not proper. It was missing a lot of files.
Okay.
And it seems like a problem. So what I did is I just took it from the 32-bit, although my machine is 64, the zip installer, and I, instead of building, I just updated the folders. And then I imported the path and it's running fine.
Okay, got it. You want to showcase, I mean, you want to share your screen and tell us like what you've done exactly?
Yeah, sure, I can do that.
Okay.
Okay, I'm sharing my screen.
Let me just stop sharing. Yeah, okay, I can see it now.
Can you guys see my screen?
Yeah.
Okay. So initially, I just did this and this two installs for the GraphViz and Pilot+. And then I went to the local install folder of my Ven.
Yeah.
Which looks like this. My virtual environment live site packages. Inside the site packages, you have all the libraries.
Yeah, GraphViz, we can see that.
Yeah. So here I just went into the website. Okay, so it's the GraphViz website. I went here. I mean, So if you just type here graphviz .org, yeah, um, in the download section for the source codes, you have these available, but for the 32-bit machine, you also have a zip available. So I just downloaded it like here this. So this is a Win32 zip file, which has got everything for the Windows 10 build. I just unzipped it in my site packages here. And then inside the GraphViz, I updated everything.
Got it.
And once I do this thing, I come here and then I explicitly, I just took my OS path. So I just use recursively. So I just first print the path, what the path is, and then I uh, just added the path variable to the bin folder. Then I again try to print the path till the time I was seeing this, that I have the path available here. And once it was there, I just run this graph and it's rendering it beautifully.
Nice. Thanks for sharing, Krishna. That's really helpful.
Yeah. Thank you.
Awesome. Okay, great. Any more time, people? Do we require for reading through that, or you have done it? And let's see if anybody would like to share their understanding first. What is a tree? How does it work out? What are the pros? What are the cons? What are the main metrics? Anything of that nature, if you want to share. Or if you're still going through, you can.
So, officer, you are there?
Yeah, tell me.
Yeah. So with respect to the installation in parallel, I was checking what to do in the Conda. So what I did was I went into the Anaconda prompt, right? Instead of the usual prompt and where it recognized the Conda command. So what I did was I did a Conda install Python -graphlib. Okay. So when it went through the process, then I am doing from sklearn.tree import export graphlib. Then I'm exporting the file when I exporting the this thing model into the tree.dot. Then I'm running this command and I'm doing this tree underscore dot current dot png. Then I can see that in my local folder here.
Okay. Yeah. I see
so
that.
I'm
Yeah.
also having the 64-bit machine, but got it done by installing the Conda install.
Yep. Absolutely. Thank you, Ganesh, for sharing it. And there's another one which is there in one of my blogs. If you're not able to plot for whatever reasons, you can actually submit the data on their website on the GraphViz URL, and you can plot it from there as well. But good to know that, I mean, at least you found some solutions to get it working for the Jupyter. Thank you.
Yeah, thank you.
Okay, who would like to talk about what is a decision tree? Where do we use it? What are the uniqueness that we have in this? Anyone? First online and then in the class. Anyone online who would like to share what you understood?
So what I understood, it is kind of like a binary classification kind of thing. So at each node, it does two classification. So it can either go the data which comes in, it can either go to left or right. And at every node, the impurity will come down.
Yep.
So impurity in the sense like, okay, we are able to classify the data.
Yeah.
And it also says like it overfit the data.
Okay. All right.
So, and this model might not be good sometimes for the new data, which might have the variance or like a different kind of data set, which were not used in the training time.
Yeah. Okay. Thank you, Nidhi. Anything else? Thanks for sharing that view. Nath, you want to go? Not necessary. Not necessary. Non-parametric doesn't mean that. Not what does non-parametric mean? Anyone? Anyone? No, but that's good try. But non-parametric is in a different sense. Maybe you are confusing that with some other non-parametric one. Let's see. Full screen mode. Full screen mode. Yeah. New. Okay. There we are. Right. So I'm just gonna look at this and see if I can jot down some of the things that you've spoken about. I just have too many things on my desk, so just let me clean up a little bit. Yeah, hopefully that should do.
You'll do the screen sharing, sir?
Okay, I am not. Now it should be visible, right?
Yeah, we can see it.
So decision tree, first of all, I mean, you can understand that it works this way, right? I mean, that you have a root node and then it will continue to split. And in this one that we are looking at, it will always do a binary split. And the model that we're using for doing the decision tree in sklearn is called CART, which is a classification and regression tree, right? C stands for classification and regression tree. So it can do both classification and regression, right? It is a supervised learning algorithm. So that means you have to tell, Amarnath, to your point, it very clearly that this is what my X is, this is what my Y is. Then depending on the Y, whether your Y is a categorical or your Y is numerical, you can look at classification or regression, right? But you also highlighted that this is non-parametric, which is one of the most important thing about a decision tree. Non-parametric meaning that it says that I know that you're saying that Y is a function of X, X1, X2, X3, so on and so forth. But I am assuming no particular relations. So Y doesn't have to be related to X in a linear way, or Y doesn't have to be related to X in a logistical way, like in a logistic regression, right? It could be any relationship that you have. As long as there is any relationship between the X and Y, decision tree will be able to figure it out. So that's why it's also called a non-linear. Unlike a linear regression model, decision tree is a non-linear model. It doesn't assume the non-linear relationship between the X and Y. It says any relationship is fine, right? So for example, if you have, X and Y related to each other like this, DT will work on this. However, linear regression will fail. It won't work, right? Even if you have a perfect linear relationship, both DT and LR will work, right? Or if you have relation like this, where something goes and does like this, DT will again work on this. LR will fail. That's what the non-parametric really signifies, right? It doesn't assume a particular shape of the X and Y relationship. As long as there's any correlation, it will be able to detect it for you. That's the beautiful thing about the linear regression model. It's a non-parametric method, right? So that's where it basically has a lot of utility coming in. Okay, let's move on. So you can read through it. I mean, this is the definition from the Wikipedia, right? So it's gonna give you a decision flow. Like, I mean, if it is sunny, I will go out to play. However, if it is sunny and the temperature is too high, then I'm not gonna go out, right? If it is sunny and windy and cloudy, I will play. Something like that. So if and conditions is what basically a decision tree will give it to you. There are many different algorithms, folks, and each one of these algorithm is having certain utility. But most common is what I'm gonna highlight over here. Okay. So there are many different algorithms, right? And you can read sort of like an appendix that I have in more on that. So these are non-parametric, and that's where I was saying that assumes no particular relationship between the features and the labels. It's assumed that there's a relationship. There is a relation that it assumes, but what type of relation, that it doesn't assume, right? So it could be linear, nonlinear, exponential, quadratic, any other shape, right? It's a supervised learning algorithm, as we've spoken about. It can be used for classification and regression modeling, both of them, right? And there are many different algorithms. These are the two most commonly used: CART and CHAID. CART, as we've spoken about earlier, stands for classification and regression tree, and it uses the concept of impurity or noise, right? And it will try to split the tree into the branches so that the impurity goes down as the tree progresses, right? And you'll see some demo coming in. And this is basically the application in sklearn. So you don't have any other option. When you're using sklearn library in Python, it will go and do a card for you. It will not do any other algorithm, right? You cannot choose, hey, by the way, I want a shade. That is not a inbuilt functionality unless you develop a package yourself, right? Which can be done. This is something which is available in other tools like SAS, right? Or eMiner and some of the other tools, it is available. This works on a very different concept, which is the chi-square automatic interaction detector, right? Or detection. What is a chi-square? Does anyone know? Chi-square test statistics.
Sir, test of association.
Correct. That's exactly right. So it uses the chi-square test of association or independence, right? Like, for example, if I look at, are men more likely to smoke than women, right? So smoking, non-smoking. And then I have these four blocks. And if I want to really establish any correlation, then I'm going to do a chi-square test of independence, right? So it basically looks at what is the expected, what is the observed, what is the actual, and then based on that, draws that. But we're not going to focus on that. But that's what the concept of a chi-square is. ID3, C45, Mars, these are all the different applications of a decision tree. But really speaking, this is what is the most important, right? And that's what we're going to focus on. So I'm going to talk about this and how it works. But before we go to that, what are the advantages of a decision tree? They are easy to build and easy to interpret. One of the easiest algorithms to put in front of your stakeholders, and they can also understand what exactly you're trying to say. The moment you say, by the way, I have taken a log transformation, then I have to take an exponential to get the probability, all of that, they will get lost, right? So it's one of the most easy algorithms to build and interpret, and it will give you the human interpretable business rules. Anybody can take a look at that tree and then know exactly what is happening. They are not that sensitive to the outliers and missing values. As long as you can actually run the algorithm, they say, okay, you don't have to necessarily do the outlier treatment, missing value treatment, so on and so forth. I will be able to give you the result, right? It can handle both numerical and categorical data, independent and dependent. It is going to give you the role and the importance of each of the variables, which are like, very, very interpretable white box model. There are two different types of models, white box and black box. What is the difference between a white box and black box? Right. So the black box models may give you very, very accurate results, but you don't know what variable came out significant. What is the relationship? What is the coefficient that they are having, right? They're not very interpretable. So it works, but how it works, that's magic, right? So they do not necessarily fly when you are having the models that need to be opened up and shown to your stakeholders, to the regulators, to the government. How did you make that decision, right? Then black box model will fail, and you can get in trouble because your models are not necessarily very interpretable. But decision tree is very, very interpretable because you know exactly what it has done, and it's non-parametric as we have spoken about earlier. What are the disadvantages? It may overfit and hence become unstable over a period of time. Overfit. What is the overfit? What is underfitting and overfitting? Yeah. So
Sir,
let's assume. Sorry, go
when you
ahead.
have very high scores for the training and less for the test, it's overfitting.
Yeah, that's exactly right. Right. So, for example, let's say if I'm looking at, I'm just making up something, so you don't have to literally take it like this is the overfitting in all the cases, right? So let's say my data points are like this. A good model should be like this, right? It's not necessarily trying to fit each of the data point. It's able to generalize that there is a general linear trend, right? An overfitting model, on the other hand, may do this. It may say, okay, let me just do this, right? This is a great model for your trained data only because it has learned too much trained data behavior. The moment I give it some new data, let's say I have these yellow points, right? Now you can see this generalizable model, which is this model, let's say a linear model. You see that it still fits the yellow point pretty well, actually. If I just have that linear line, and still, like, I mean, the error that I'm looking at is not that much compared to that linear line, right? However, imagine this data now and how much error you're gonna get, right? So it's overfitting. It's doing a fantastic job for your training data, but it doesn't do a good job for your other data or unseen data. And any model that you build in the real world should be following one characteristics, which is it should be a generalizable model, because the model that you're going to develop is not going to be used just for that data. It has to be used for other data as well. So it has to be fitting those data very well. And that's where, sometimes, a decision tree may overfit, right? May overfit. It's not like, I mean, decision tree will not work out all the time, right? In fact, if you look at most of the Kaggle winners, right? They will have a version of a tree. They will either have a decision tree or random forest or gradient boosting tree or GBM, right? I mean, all the different version, or XGBoost. They are nothing but the trees, some format of the tree, right? I mean, those are more advanced trees, but they're nothing but the trees. So they are still very, very important and very, very usable models, but they may have certain shortcoming that we should be aware of, right? They may become unstable depending on how the population and the variable distribution changes over a period of time. They may favor variables which have more levels and more categories. Right? What does it mean, more levels and more categories? So let's say I have a variable x1 which ranges between 10 to a large number. What is this number? 10 million, right? Let's say variable x1 ranges between 10 to 10 million. X2 ranges between 10 to 100. Generally speaking, they will favor these variables more. That's another shortcoming of a decision tree, right? But what you can do to fix this? Anyone? Can it be fixed? You can do the
limit
by
the limit the depth.
Yeah, or you can do the scaling or normalization. So basically, what you're doing is you're just fixing the min and the max value. So because when you do the scaling, what happens? Let's say I'm doing a scaling of 0 to 1. So this value will become 0, this value will become 1. This value will become 0, this value will become 1 for those variables. Now it's apple to apple comparable, right? So now it's not going to favor variable x1. It will be equally sensitive or not sensitive to both x1 and x2. So that's one way of fixing that, which is a normalization or the scaling of the variables. Um, Generally less preferred when you want to get higher precision, higher recall, but that's still something that we can work with, right? And card. So we're going to talk about this, and I'm going to ask you some quizzes on this. Let's see if you can figure out how this math really works out. So card is what we will be using, and it works on the concept of impurity as we have spoken about earlier, and it will find. So for example, if I show you this tree that we built in the Python just now. Over here. So in this data, for example, if you remember, and let me see if I can grab this picture and put it there. So we just did this tree. So how do you know whether I should break it by petal length or petal width, right? So remember, in this data, what we had was classes or the type of the flower, which was Setosa, versicolor, and virginica. And we had 4 independent variables: petal length, petal width, sepal length, and sepal width, right? How do you know whether I should break by the petal width? Is basically it will look in, I think that's where some of your questions were coming in. How did it know that I should break it by this? It will do that iteration internally It will say, okay, overall impurity in this system is this much. And then you will compute this impurity in a minute, right? So it will say overall impurity in the system is this. And higher the number, higher the impurity. Higher the Gini, higher the entropy, higher the impurity, right? So it says my system is this much impure. Now, if I break by petal length, what is the drop in the impurity I'm getting? If I break by petal width, if I do by sepal length and sepal width, and it will automatically test the different cuts that it can apply in the variables itself to figure out what should be the right variable to drop the impurity the highest amount. And that concept is nothing but what we call as an information gain. What is information gain? That is the drop in the impurity that we are getting from one branch or the parent branch to the child node. So that's where the concept really comes in, and I have articulated that over here. So it will split using the variables, using the cuts in the variables, which basically will drop the entropy and the Gini the highest, right? And that's the concept over there. But how do we measure them? These are the couple of formulas of the, like, couple of metrics that you can use. Entropy is negative P log of the P on the base of 2, negative Q log again on the same base. And Gini is nothing but 1 minus summation of the probability square, right? And we'll do some examples to really sort of like make sense of that, right? Hmm? No, entropy is the impurity. So, and I'll show you, for example, over here, right? I mean, I will jump ahead. So if I have a system where there are two events possible, let's say this class has 5 boys or 5 male and 5 female. Is this pure system or impure system from a decision tree point of view? 5 male, 5 female out of the 10 people present in the class. Is it pure or impure? Impure. 100% impure from the decision tree point of view because it's a 50-50 probability, right? So for example, you can see if there are two events which are possible, and I have a probability of event A to be 0.5, probability of event B to be 0.5, entropy will be 1, which is the maximum amount of impurity that we're looking at. Now look at this scenario where only one event is possible, almost like a probability of 1. Entropy will be 0, Gini will be 0, right? So that's what it is trying to accomplish, decision tree, to drop the entropy and the Gini, and that drop is nothing but the information gain. So it's trying to separate out the classes from each other, right? So the moment it's trying to separate out the classes, that's trying to do a correct classification because everything was mixed up. So let's say we have a dogs and cats mixed up. The model is trying to separate the dogs and the cat. As it is separating, entropy will become lower, Gini will become lower. How would it know which split it should take? Where that drop in the entropy, drop in the Gini is the maximum. And that concept is called the information gain, right? Now, looking at this formula, let's see who can tell me the flowers. You can just tell me the entropy. Everybody has a good handle on the formula for entropy. You can access from the weblog, from my blog as well, from the website. Uh, who can tell me the entropy for the iris data in the original root node? Just work from this math. What will be the entropy in the iris data original root node? So how many flowers are there in the original root node in the iris data? 150 flowers total. How many are setosa? 50, versicolor 50, virginica 50. So first of all, is this a purest system or impurest system? Who tell? Highest amount of impurity, right? Because I have 3 species and all 3 species are equal number. So what is that entropy? And what is that Gini? Anyone compute that in the Excel and let me know? This is a formula right here. So I'm talking about this node where we did the iris flower. We have 50 setosa, 50 versicolor, and 50 virginica. What is the Gini and what is the entropy of this original node? And you can work with this formula. So the Gini will be computed using this. Entropy will be computed using this, where P is nothing but the probability of each event, Pi. Similarly, you can see P, Q, and then you can say, I'm going to have another one, which is, let's say, D. Right? Nobody stops you from having another event. That's nothing good enough hint to compute. Hmm? No, not 50-50. 50-50-50. All three flowers. Yeah. 50-50-50. Minus 8.2. 8.846. Minus 846. Okay. Let's see if others also confirm that. You have to be doing it on the base of 2, not 10. Okay. Let's see. But you have to compute the probability. So not 50. Probability is 50 by 150. 50 by 150 is the probability for each event. Hmm? 1.5 entropy. Let's wait for others to confirm. Anyone has any other numbers? How many of you are working actually? You doing civil, sir? Danish? Aditya? Amit? Amit, right? It's really confusing. Name tags are from some other class, right? So you have to constantly remind. 1.5. I don't know whether that is correct or incorrect, so we'll just have to confirm from others. One minus summation of all the probability square. So 3 events, 3 probabilities in that original data. So take the probability of each of the events, square it, and then that is 1 minus probability 1 square, 1 minus, 1 minus probability 1 square minus probability 2 minus probability 3 square. Yeah, absolutely. Okay, so the question was the system where we have 30, sorry, not 30, 50 Setosa, 50 Varsi or Versi, whatever the spelling is, 50 Virginica, right? 0.66. Okay, that's correct, I think, right? So Gini is nothing but 1 minus your I will vary from 1 to n.
0.6666.
0.666, okay. So let's do that. I think that's correct because we saw that there in the previous chart as well. So the probability of first event is nothing but 1 by 50 square. But because all the 3 probabilities are the same, so I can simply multiply by this number, 3. So the probability comes out to be the Gini comes out to be 0.667, right? Let's confirm that. If you look at our tree, the tree that the Python built, it says the Gini is 0.667, right? So that's how basically the Gini is being computed, right? Everybody is with me? Now let's do the entropy. What will be the entropy? Minus P log of P on the base of 2. So that means basically minus 50 by 150. Hi, Shinu. Log of 50 over 150 on the base of 2, and then I can simply multiply that by 3. What is that number? Minus 1.5. Let's do that math. You are also getting minus 1.5? Okay, let's do that math very clearly. So it's nothing but minus. Okay. So then 50 divided by 150 times log on the log of the number, which is again 50 divided by 150 base of 2, right? And then we have to multiply that by 3 because we're doing it 3 times, right? All 3 probabilities will be the same. Yeah, it's right here, just the color is okay, there you go. So 1.58 is what I'm getting. Is that the same? So everybody has this number, 1.58, and how we got it? Which goes back to the same formula that we are looking at over here, which is probability of first event, log of the probability on the base of 2, second event, and then third event. So you can see PDQ, ABC, whatever that we have. I mean, all of that will be coming in naturally from there. Fine. So that we can actually see, what exactly it is. So now I will just take you back to this picture I was showing you. So the Gini and entropy behaves like this. Who would like to interpret this chart for me? I have done, certain computation. This is something that I drew myself. What does it really mean? There are 3 or 4 things that we're plotting over here. This is slide number 8.
So the one point is as event A occurrence is increasing, the event B will come down because
Correct.
there will be only one event.
Correct.
And the Gini, it is like almost 50% of the entropy.
Correct. Yeah, so event A probability you can see goes from 0 to 1. Event B is nothing but just the opposite of that, right? So both probabilities will add up to 1. So as the probability of event A is 0, probability of event B is 1. As the probability of event A goes to 1, the probability of event B goes to 0, right? And you can see when they are equally likely right here in the middle, 0.5 probability of A and B happening, the Gini and the entropy max out to 0.5 and 1 respectively for a binary classification, right? And that's the data basically I have plotted it from, just using the same math as you have done. So I've just assumed there are 2 events, A and B, with certain probability. And then I'm looking at the entropy and the Gini of those systems. And where both events are equally likely, the probability, or I mean the Gini and the entropy will be the worst or the highest value in that. When one event is 100% likely, Gini and entropy will be 0. That's the impurity concept. Now let's go back to this tree that we are looking at. So you can see over here the Gini is 0.667 that you have computed. Why is the Gini over here 0?
Because
Anyone?
one category classified clearly.
Correct, correct. Because there is no impurity. Like there are 50 data points and all 50 data points belong to Setosa flower. So 100% pure system. That's why it's not splitting further. It says there's no need for me to split further because I have 100% pure system. There's nothing I can do. Gini is 0. In this case, Gini is 0.5 and everybody can see why it's 0.5. Remember this
50,
chart?
50% chances.
Exactly, exactly. So in the 2 classes, Gini will max out at 0.5 if they are both equally likely. So I have 100 observation, each one of them are 50-50. So the impurity is highest again. So we are back to square one. So we started with the highest amount of impurity here. This node became 100% pure. This node became 100% impure again, because again we have 50-50. So it will continue to split further, right? Over here, you can see the Gini is approaching towards 0. It's never 0. I mean, it will very rarely get to the 0, but it will approach 0, right? This one is Gini lower. So which one is more pure system? Between the green and the purple? Purple is more pure, right? Because Gini is further closer to 0 compared to this one. And there's no point to split further here because you have only one observation which is not belonging to that class. So that's why it's not split further. Over here again, you can see the Gini is 0.168, and then it becomes pure here again, 100% pure system. So that means all the versicolor 29 flowers which are here, all of them are versicolor. Over here, there is still some mixed bag between the versicolor and virginica, right? So that's how basically a decision tree really functions, right? Let me just cover some of the
I guess in
yeah,
your code, the code which you were executing, there you have given depth 3. So that is the reason after 145, it is not going further.
right. I have also specified some of these things, which I will talk about what really it means to control the tree, which is the pruning of the tree. So that's why it's not going forward because I've pruned it, right? What is pruning of the tree, by the way? Just in the normal terms. Yeah. So if you let the tree grow, then it's gonna grow in all the different directions, right? And it will become too big of a tree, and it will be very, very difficult for you to control that, and it will be overfitting. So that's why you have to prune the tree, right? And pruning the tree is many, many different ways that I'll show you later on. So far we've talked about the entropy and the Gini, which are only valid for the classification problem. I can do the regression as well. But then how will the regression work? It will use metrics like this, mean square error or mean absolute error. It will try to minimize the error. So when you start with a system where everything is mixed together, your mean absolute error, mean square error will be higher. As you get more and more pure, that error will drop. So it basically tries to modulate one of these metrics, and we'll see which one it takes by default to lower it as the tree becomes purer and purer going down the branch. Does that make sense, people? For regression, how it works? Here? The actual tree?
So the classification works on probability.
Classification works on the Gini and entropy, which is actually tied to the probability.
Okay, and that is actual versus predicted.
Yeah, and regression will be based on errors, just like what we have done in a linear regression model or a classification model earlier on. Classification always works on the probability. Regression works on the error. Amarnath, your question is answered or no? All the classes. For Genies computed in that system, this is one system. What is the Gini of this system? Which is the highest amount of impurity, and you computed that as 0.667. What is the Gini for this system? 0. If it is 0, no further split possible. Here, Gini is back to 0.5 in a binary class. Why binary class? Because we have only two classes over here. Again, the highest amount of impurity for the split, right? And so on and so forth. So Gini will never get to the 0 in most of the ideal, I mean, in the real world situation. Ideally, I mean, it should get to the 0, but the real world situation will never get to the 0, and we'll control the tree as well. So you'll never get to see this level of purity coming in. We're gonna do that on the Titanic. It's not gonna be like that. Yeah. Any other questions, folks? So we just spoke about. Sorry, I think I'm just moving too fast. We spoke about what is a decision tree, algorithms, advantages, disadvantages, card, how does it work, Gini and entropy concepts, then some calculation to see how these charts are drawn, which basically helps you figure out what is the level of impurity, looking at the Gini and the entropy numbers. And for regression, the error components will be coming in. And this is again a recap of how it works, right? So it chooses the best split of the features and the values to maximize the information gain, or maximize the information gain is nothing but to maximize the drop in the entropy, or drop in the Gini, or drop in the error, or the drop in the impurity overall. Information gain is just opposite of the impurity, right? So if the impurity is getting reduced by maximum, that means information gain is getting highest. So that's how basically the algorithm really works out. Information gain is nothing but the impurity between the parent node and the weighted average of the child node. So let's do this math. What do you think is the information gain from this to this? Who can tell me the math? What is the information gain? Is the entropy of the Gini in the parent node and the weighted average of the child node. So what do you think will be the information gain in this from this? Let me just take a snippet. I have already taken actually. So, and this will be helpful for you to understand. Yeah. Right over here. So my question to the class is, this is Gini of 0.667. This is Gini 0. This is Gini 0.5. What is the information gain?
Information gain for orange box will be 1.
Will be 1?
I guess. Yeah. For orange box, where the Gini is 0.
Yeah, no, but I'm saying just, this level of the tree. So this is called the depth of the tree actually, Nidhi. So this is the parent node and this is the first child node.
So here it
Or
should be 0.
right. So the information
Parent
gain will be parent's entropy, which is
0.
0.667 minus weighted average. Um, I don't know what is this. Minus weighted average. What is the weighted average? So it's 0 times 50 divided by 150 minus 0.5 times 100 divided by 150. Correct? Or I mean, it shouldn't be minus. So this is the weighted average. This is minus over here. So this was the overall Gini when we started. This is the Gini of this system, but I'm doing a weighted average because only 50 observations are here and 150 observations total. And then this is the Gini of this system, and then 100 systems, 100 observations are there compared to the 150 system. So the information gain is nothing but this turns out to be 0. Anything multiplied by 0 is 0. And then we are looking at 0.5 times what? This will be 1 by 3, 5 or 2 by 3, sorry, 2 by 3, right? 5 to the 10, 5 to the 15, 2 by 3. So this is 0.1 by 3. So 1 by 3 is nothing but 0.667 minus 0.334. So you can see basically the Gini has become roughly the half when I went from the parent node to the child node, and that is the information gain.
We
So
can
you can
clearly say like 50 flowers are clearly identified. So
correct,
33% is the information gain on the
correct,
second
correct,
level.
correct, exactly right. So then similarly, you can compute the information gain from over here. So this is the parent node for these two child nodes. Then I can say, that I'm looking at this as the original Gini. And then what is going to be the information gain over here? So let's say I'm going to focus on between this to this level. So the information gain will be nothing but 0.5 minus, who can tell me the math? 1 0.168 times 54 divided by 100, because that's how the original system was broken, plus 0.043 times 46 divided by 100. So that is going to be information gain over here, right? That's the concept of the information gain. And that's how basically the tree will actually figure out what should be the right split that we're looking at, right? Right. So we talked about the pruning and some of the other things. So why don't we take a break over here on this note for about 10-15 minutes? What time, Rashmi, shall we go for lunch? 1:30? What do you folks think? Or you want to continue and then directly break for lunch? I'm okay that way. That is better. Okay. So we can continue. So now we're gonna shift gears and try to do this on the Titanic data. And remember, you've already worked on the Titanic data. So all the things which I have over here remain the same. Everything remains the same, but you're more than welcome to again see whether you missed out something and then do that. The thing which will be different will be, instead of importing logistic regression, we're going to import a tree, right? Everything else remains the same. And then X and Y, same process, the step 1, and it's there in the same article number 35. Step number 2 remains the same, no changes there. Step number 3 is different. So I'm creating an instant called as my tree. I'm importing decision tree classifier. When you're building a regression, what would you import? Instead of classifier, regressor, right? So you'll just say, okay, I want to build a regression model, and that's the only thing that you will be doing differently, right? Min sample leave 50, min sample split 20. Don't worry about that. I will come back post lunch and explain you what exactly they are, right? Then step 4 remains the same, which is fitting the data on the train data, fitting the model on the train data. Step 5 remains the same, which is the predicting on the test data. Step 6 remains the same, which is, then you're trying to spit out the metrics classification report. Everything remains the same. And then this is where you have done things. I mean, confusion matrix is the same as well. Then pip install graph is that you have already done for iris, so not a big deal. Then we're gonna do the tree So we will grab in my tree classifier, out file none, feature names x dot columns, class name 01, because we have survival and non-survival over here. So the iris won't be applicable. Then we're going to plot the tree, and the tree looks like this, right? So gender, passenger class, fare, all of that will be coming in for Titanic, right? So this is your activity. Do it now, and after lunch also you can continue. But I want you to be coming, all of you to be having a decision tree for Titanic data, which looks like this, right? And then we'll come and try to interpret what really it means, right? That's the first segment that we'll be doing on the decision tree. Then we'll try to understand, we'll try to figure out how to optimize the parameters via the hyperparameter optimization. Then I will give you the classwork that you're going to do again in the groups on that lending data that we have spoken about that will be submitted for your grading. Sounds good? Awesome. So over to you. You can start working on the Titanic. Once you have this look of the tree, let me know whether you're good to go. The tree look as well as the classification reports, which don't look very good as of now. So you can see I'm not necessarily doing any better than logistic regression, just looking at the numbers at the ballpark, right? So logistic regression, also the recall was somewhere around 0.5, 0.6, if I remember. And tree is also giving me the same recall. So I'm not necessarily gaining a whole lot of things, but we'll see how to optimize this performance better, right? Any questions, folks? Otherwise, you can start working on it, and we'll directly break for lunch by around 1:15 or so. Yeah. So you have 45 minutes to cover your decision tree on Titanic data, and you can directly leverage whatever you have done on the logistic regression because it's not different. The only things which are different are the ones that I'm highlighting over here, which is uh, this one, step 3. Instead of logistic regression, you will call in a classifier. You can use the same settings in terms of the hyperparameters, min sample leave, min sample split. Step 6, no changes at all for all the remaining ones. Then this is where we are plotting the tree as we have done for iris data. And we will take a pause over here once we have this tree.
Sorry, sir, I have to step out for about 15 minutes. Can I step out and then come back and resume, sir?
Sure, no problem. Everybody's done? Folks online, can you confirm if you're done or anyone needs any help?
Sir, I took 10-15 minutes break to have something, so I'm just on the way.
Okay, fair enough. Anyone else who needs any help? Amit, Amarnath, you done? Almost done. Okay, so we can wait for maybe 5 more minutes.